Hello, my name is Bob Thorne and I'm a Senior Applications Engineer here at Radan. Now, I've worked for Radan for many years, and over that period I've very often been asked, what is it that Radan does? So I thought I'd take the opportunity today to answer that question for you. I guess the official response to that question is that Radan develops, supplies and supports integrated CAD CAM software solutions for sheet metal manufacturing. But I personally don't believe that that really does the software justice. So I thought what I'd do is actually show you what the software can do. And I do that with a real world component that's been manufactured by one of our customers. So I've got that component here. Let me just grab this and show you. So this is a sheet metal bracket. It's a stainless steel, 3mm stainless steel bracket which has been lasered and folded, and it's part of a trophy that was manufactured by one of our customers. So I'm going to take this and use this to show you the process of using Radan integrated CAD CAM software for the design and manufacture of this particular bracket.
So here you can see the trophy, and there is the bracket that supports the trophy, and that's the one that we're going to be manufacturing. So we're going to start with Radan's 2D and 3D CAD solution. So this is Radraft and Radan 3D. I've actually speeded this section up for the purposes of this video. I can't really design and draw this quickly. You can see here that I'm using a combination of 2D and 3D techniques to actually model this component. Using my bend parameter table, I can generate an accurate flat blank of this component. Okay, I'm now going to auto tool this part for a profiling machine, and there you can see the laser profiles around the component. Having tooled this component, I can now get an estimated manufacturing cost using Quick Estimate. Now, I know I'm going to laser cut this component, but what I thought I'd do is do a very quick cost comparison between laser cutting and punching. And as you can see in Radan, it's very quick to switch between punch and profile, so I can get a cost for either technology. I'm now going to go into true shape nesting and add this component to a project nest. And there you can see very quickly I've generated a nest of 25 components. I'm now going to automatically tool the nest to generate the NC program. Before I send this program to my machine tool, I can run a visual simulation to ensure that I'm going to cut it in the correct manner. I had some spare capacity on my sheet, so I've now combined my component with various other components in my project nest to ensure that I get a high utilization from my sheet. Having got some nests, I can now get some costings for the nests, again using Quick Estimate. From my project nesting, I can generate some nest project reports detailing all the information I need for my components. And here you see I am generating a simulation of the complete nest before I send it to my machine tool. And here you see us actually cutting those components on a laser. Having completed the cutting of my component, I can now use Radan to do press brake simulation and press brake programming of this component. So having chosen my press brake, I can get the software to automatically tool this component. We can add automatic finger stops, and we can now run a full 3D simulation of this press brake program. All the while this simulation is running, the software is doing a full clash detection to ensure that when we fold this component, there are no problems met on the shop floor. We can then generate NC code and a complete set of reports for the press brake operator. And here you can see that component being bent on our press brake. By using Radan to program our press brake, we've been able to ensure that the program is error-free before we get out onto the shop floor. Okay, so let me just sum up what we've just seen. To design my component, I used a combination of Radan for 2D and Radan 3D to generate my 3D model. I was then able to unfold the component and generate an accurate flat blank using Radan 3D. Once unfolded, I was able to get an estimated cost for manufacture for both profiling and punching. Using Radan's auto tooling facility, I auto-tooled for a profiling machine and a punching machine. I then added my component to a nest and was able to get a dissimilar true shape nest for that component. Again, using Quick Estimate, I was able to get costs for those nests. And then finally, using Radan, I'm able to create an NC program for my press brake and do a true 3D press brake simulation. So there you have it. There's an example of what you can do with the Radan suite of products. But if you'd like more information about Radan, why not visit our website www.radan.com for a complete list of all the Radan applications.